Hey everyone, welcome back to the 443 Security Simplified. I'm your host, Mark the Liberty, and joining me today is...
Corey Shiny Rainbow Unicorn, aka Bad Hair Day Knockriner.
Nice. I am also coming to you from the frozen north that is Seattle, hence the white void of a room with just two sound dampening panels, so it doesn't look
At
like a
least you
total
have
void.
sound dampening, though.
Thanks. This is the classy WatchGuard studio now. I even have a little on-air light that turns on in the hallway. It's fantastic.
Cool beans. I need that for my kids and wife when they walk in the background.
And your dogs when they decide
And my
to take
dog.
a nap.
You might hear her snoring now.
On today's
What are we
episode,
doing today, Mark?
we'll discuss a interesting evasion technique that North Korean malware authors are testing out right now. Then we'll go into a not necessarily new, but just recently reanalyzed evasion technique leveraging concatenated zip archives. And finally, Corey will put on his tinfoil hat, and we will discuss the top exploited vulnerabilities from 2023, courtesy of our best friends over at CISA. With that, let's go ahead and, I don't know, hack our way in. That sounds great.
No plow on it? Sure.
Snowplow in. It is pretty damn cold here.
I guess it's not that cold yet in Seattle.
It is for my warm Texan blood.
Wow, you converted quick.
Awesome cold elements. Don't have that. All right, so let's start this week with the first story, which comes from our good friends over in North Korea. This actually starts with a blog post from Jamf, who was describing a series of macOS malware payloads that they link to North Korea, which we'll get to in a second on why, that are using some interesting evasion techniques to remain evasive. So the story starts with they discovered several malware samples that had been uploaded to VirusTotal in late October that came back with 0 detections despite containing malicious code. They came in 3 different forms. There was a Golang application, a Python application that was using py2app to become a executable file, and then a Flutter application. And the reason this story caught my eye is because up until now, I had actually never heard of Flutter as a framework for app development. So if you, like me, were not familiar with Flutter, it's a framework that was developed by Google to help with cross-platform applications. Basically, if you want something that looks the same on macOS, iOS, Android, whatever, then Flutter is a framework you could use to help build that application to make it cross-compatible with all those different apps with functionally the same like presentation and even like runtime code too. And the application structure is built in a way where the actual code itself lives in a dynamic library. It's actually using a program language called Dart, which is similar to JavaScript or Python, where it's typically run using a just-in-time compiler when it's executed. And then there's kind of a parent application, let's call it like the Bootstrap application, that lets it run on a specific operating system. So in this example, there was a macOS file where it had that macOS Bootstrap that's basically the Flutter engine, let's call it. And then it would load up this dynamic library that contained the actual app that it's trying to run. Interestingly, like one other kind of evasive factor in this is, unlike other traditional macOS applications, which all have a manifest that tells like the computer and anyone that reviews the application, like all of the libraries that are a part of that application, because of how this is built, these dynamic libraries aren't actually a part of the manifest that macOS reads. And so if you're using say a defensive control, or you're manually reversing this and you're not specifically looking for it, you might miss some of these as actual executable code that gets loaded in. So 5 of 6 of these Flutter samples they reviewed were also signed using valid, at least at the time, developer accounts, which Apple has since revoked. There was one, it was like Baltimore Jewish Council. There was another one that was Fairbanks Curling Club. So random companies out there that presumably had either I mean, I guess I shouldn't make assumptions.
It was unclear that these were like if this sometimes people will steal a real
Yeah.
company's signing key or get access to it. It's unclear if that's this or if this was just made up company names.
Exactly. I was going to say that it was probably like a compromised certificate, but as I was halfway forming that sentence, I realized this totally could be just like, I don't know, North Korean shell companies
Setting
that they
up a
spun up.
company, yeah.
If I was thinking of a random company to fake, like Fairbanks Curling Club Incorporated, sure sounds
Seems
like a
like a
fake
pretty
enough
good
company.
one. Yeah,
Yeah.
it's one of those things that would exist, but just seems so unusual. No one would ever check it or suspect it to be North Korea.
Yeah. But, anyways, they had legitimate developer certificates, which basically meant that they had registered, either stolen them from someone that had, or gone through the process of registering as a macOS developer. It's like $100 a month. There's a little bit of vetting that goes on from Apple to make sure that like the company is registered somewhere. It's got like a business registration, whatever. And then it lets you submit a compiled application to Apple to get notarized, which is basically cryptographically signed. There's some validation Apple does as a part of that process. Like they make sure that the manifest is okay. They make sure it's not asking for too many extreme permissions in that manifest. They do presumably a little bit of like anti-malware scanning, but obviously it's not perfect. And because clearly macOS malware still exists to this day. So in this case, though, one of the examples that they showed, it was an app called New Updates in Crypto Exchange, August 28th, which is my birthday, which was a clone of a open source Flutter Minesweeper game that's available on GitHub. Basically, they took this open source game and they injected their malicious code into it, so it was still a functional game, but it had something else running in the background. That something else would make a request to a domain, mbupdate.linkpc.net, which is a domain that is known to have been used by North Korean malware authors in the past. I think I saw a report from like October of last year where they were using it in a few different attacks. This specific endpoint that it was making a request to was taken down by the time that Jamf researchers took a look at it. But they suspected that it was hosting a AppleScript executable based off of the strings output of that application. So they set up their own, Jamf set up their own destination to like mimic what it might be trying to serve up to this stager, basically. And they confirmed that it does execute AppleScript that's returned to it, but only if the script is written backwards. It's actually pretty funny. They gave an example where it's literally like it opens up a window, a dialogue that says like this message is from the server, whatever. And they show in their screenshot that Corey's got on the video here, where they literally take whatever the script is supposed to be and just like mirror it entirely. And that's what gets delivered to the endpoint. So another, I don't know, crappy, fun evasion technique for that one. It's not really practical in terms of actually evading threats, in my opinion, for anyone that's looking at it. But another step in there. The Golang variant, by the way, it also executes any AppleScript that's returned to it. It was just titled Hello as an application. The Python one, it launches a functional Notepad application, but in the background makes a request to that same domain and executes any AppleScript return. So basically, all of these look like they were like development or testing applications to like test their capabilities of getting something running on macOS that could then execute AppleScript that's returned to it. And again, in each of these cases, like this stager is what it is, came back with a 0 out of whatever result on VirusTotal. So it presumably evaded all anti-malware engines there at the time. Probably being cryptographically signed by a valid certificate was a major bonus for it. But then the reality is it really wasn't doing a whole lot other than making a request to a web domain and then executing AppleScript that returned to it. So I guess one other interesting thing. So when I first started reading this article, I was trying to figure out like how do they know, like how were they looking for this? Because like millions of things get uploaded to VirusTotal every single day, and like how do they happen to stumble across these? And I'm imagining they were aware of that domain, and they were probably searching for files that reference that domain. and they stumbled across these ones where they had 0 detections. But in VirusTotal, if you've got an enterprise account access to it, it'll show you all the behaviors of the file, and you would have been able to see that request out to this domain. So that would have been a factor in it too. But so long story short, one of the interesting bits for this is like Flutter applications are actually really difficult to reverse engineer, it turns out, because it's using pre-compiled Dart snapshots is what it's called. So Dart, I mentioned, it's a programming language where you can parse code into like a portable, let's call it intermediary format that the Dart virtual machine can quickly load up and execute. That's what the snapshot is. Basically, just like other just-in-time compiled languages, generally when you're running the script, in the background, it is at that moment parsing and interpreting all of the functions and classes that you have, compiling it into like bytecode, and then running that bytecode within the virtual machine on the computer. And a snapshot in the case of Dart is it basically takes all of that and has it ready to go in a format that's still portable, so you could run it on Mac OS or iOS or Android, whatever. And that makes it actually really difficult then to reverse engineer it out of here. So Jamf, literally all the reverse engineering they did was just run the strings command, because trying to decompile that was pretty difficult. But I guess the main takeaway from this, Corey, I'm curious what your thoughts are, is that it's clear that like these nation state threat actors are testing out new ways of delivering malware and trying to be evasive. This is clearly a successful way of making a evasive file, but it was also clearly just them testing it. Like this was not a, let's call it production malware attack. It just happened to be someone uploaded the files to VirusTotal as they were developing it, and that's how Jamf got a hold of it.
Yeah, like you say, it's an interesting evasion tactic. I'm not sure what users should do, because I don't think it'd be obvious to them whether the stuff they download is made with Flutter or not. But I presume Mac's gatekeeper in any Mac OS based security software, understanding that Flutter applications use that actually load a different application, they're, that dynlib, whatever, from a certain location, they should start probably scanning those. If they can do something to detect Flutter apps, ignore the main application and go find whatever dynlib it's going to actually load.
To give an example, like I don't know exactly how WatchGuard EPDR would have handled this, but understanding how EPDR works, like even if this initial stager wasn't detected or wasn't at least flagged as malicious, because
Apple
it's not really
script.
doing a whole lot, that URL download, so connecting to the malicious domain, would have been one indicator. So the domain itself, like we would have blocked that. That's no malicious. But let's pretend that it's brand new. That request that goes out is a behavior that is analyzed by EPDR. So it would review that. And if it thought it was malicious, it would flag it. The file that is downloaded, that Apple script, because it's executable, would be analyzed. And if it was determined malicious, it would block it right there. And then if that stager managed to load in the Apple script, start executing it, and then Apple script's just a way to like do things on Mac OS. So like using other tools like load up
Same as
bash commands.
JavaScript or PowerScript,
Yeah.
so just Apple's version. Not same
So
literally, but you know what I
the
mean.
activities that the script would have done also could have been caught and blocked. So there's a bunch of different layers to still catch this threat, even if that initial stager, because it's not super malicious on its own, even if that managed to execute, doesn't necessarily mean the full attack would have succeeded.
I am also interested. It's not our job. I mean, Apple will follow up, I'm sure. But if those actual, digitally signed, those developer signed certificates, if they were stolen or made to Apple, I mean, they either need to improve their vetting process, or hopefully the companies that had them stolen have figured it out by now.
I've been through the
Apple
vetting
has
process
revoked them.
before. I made an application for Mac OS a few years ago, and literally all I had to do was I'd set up an LLC, which I don't even think I had to prove my identity for that. And then using the LLC, I registered for an Apple developer account, and I didn't upload a driver's license or anything there. So like I did not have to prove my identity anywhere along the way. I just paid him $100 and pointed to a business entity, and I was able to get one of these accounts that then let me notarize applications. So I wouldn't be surprised if North Korea or other threat actors had the capability to set up shell accounts or organizations to that seem legitimate that are being used for malicious purposes. So maybe there is something else Apple can be doing. I don't know. At some point, it becomes, I mean, maybe privacy invasion is kind of important for something that gives like elevated, maybe not permissions, but access to Mac OS, bypasses defensive technique. I don't know. Maybe there is more vetting that could happen. Or maybe these were just stolen and there really is a Fairbanks Curling Club LLC that develops applications for Mac OS somewhere. Who knows? But either way, interesting research from Jamf.
For sure.
Moving on to the second story. So this research came from an organization called Perception Point, and it was on zip file concatenation as a malware evasion technique. And it's not necessarily a new technique, but I thought they went into pretty good detail describing how this technique works on helping deliver malware onto some victims while making it difficult to spot on other systems that might be analyzing it. So it exploits the different ways that different zip archive readers process concatenated files or concatenated zip archives. And as a quick architecture overview of how zip works, basically a .zip file, it contains file entries. So that's like the actual compressed files that you have within there, like text files, images, whatever that you would have, along with some metadata for them, things like file length, file type, that sort of stuff. I think like creation date and update date are in there too. Then there's this central directory section of the file, which is basically a index of the entire zip archive. It's located at the very end of the zip, and it lets zip archive readers locate and extract files without needing to scan the entire zip sequentially. Basically, let's say I have a zip archive with 20 different files in it. If I tell the archiver that I want to pull out file number 13 in there, instead of having to scan through the entire memory location of the zip, find 13, pull it out, I can just go to this index, go, okay, that's it.
If we were showing the blog post, basically it's all the files are at the beginning of the file in order of file 1, 2, 3, and then the central directory is at the back, basically telling the zip how to find everything.
Exactly, yeah. It's like a directory, like a white pages or whatever for a potential zip
Here we
archive.
go. Now, if you're on the YouTube video, you can see.
Yep.
Thank you, producer.
Exactly. So the end
By
of
the
that
way,
also
talking
has
about research from Perception Point about the evasive zip for those catching up.
Yep. The last bit of the zip archive is called the end of central directory or EOCD record, which basically just marks the very end of that index. It contains some metadata like the number of files and where the start of the central directory exists. So that's a single zip archive. Think of it as a whole bunch of files in the front that are compressed, and then these white pages at the end that tells you where those files are within the memory. So the researchers focused on concatenation, where you take multiple zip archives and stick them together. So now it's a single file, but in that file, there's actually two different central directories. And it turns out that
concatenation is different than recursive zips. Like a zip within a zip within a zip is different than zips
Correct.
Put together as one file.
Yep. This is literally taking, and they give an example of like just two really simple zip archives, each of them only containing a single text file, and then squishing them together using just the Linux cat command into a new zip file that is the combination of the two of them. So if you're thinking of the structure, it would have a central directory at the very end, and then would have a central directory somewhere like in the middle of the file from that first.
Can I pause for 2 seconds to say, this isn't kind of officially as like a recursive zip file. A zip within a zip is something any zip program, and they tested a number of zip programs, would do. Concatenation is not like part of the zip standard. This is you're literally doing this outside zip. Now, that doesn't mean zip programs won't interpret it in a certain way, but this is a function. Zip files aren't made to be put together, essentially. They're just doing it through a Linux command.
Technically an invalid file, but a lot of these applications are built with things in mind, like maybe a bit gets flipped somewhere and there's like some corruption in the file. So they've got like some built-in error handling to try and do their best with files that aren't absolutely perfect. And so in this case, it is a file that is not absolutely perfect, and different archiving utilities handle it a little differently. So the researchers focused on like the three main ones. So 7-zip is a really popular archiving utility. WinRare, I think, is probably the most downloaded file that no one has ever paid for in the history of Windows computing. And then Windows File Explorer is another technically built-in zip archiver that can even handle them in weirdly named file formats as well too. So, for example, the one they had those two zip archives, and they said the first one is benign. Let's just pretend it's a normal file. And let's call that second one the malicious file. We're trying to get to the victim. When you open up their example one in 7-zip, it actually shows that first archive. This example, it would show the quote unquote benign file. When you go to extract it, it does give a warning. It says there's some data after the end of the archive, but if you're not paying attention, you might miss that or just have no idea what the heck that even means. But in this case, it's actually reading that the central directory in the middle of the file in this case instead of at the end. So presumably,
does that mean it's 7-zip would have handled this in a good way, meaning it ignores all the data at the end?
I don't know,
And that's not getting the second, because they never say in this, they never, they're not alluding that at the end of the day, do both get decompressed, or does it just decompress first.txt and it can't find second.txt, which is the evil one?
Yep, it only decompresses the first.txt and it pretends like that second one doesn't exist. It's just garbage data on the end. And I don't know if we would
7-zip might be okay for this.
I don't know if I would call it the correct way of doing it or not. Like, it sounds like the zip file format was designed to be read like back to front, where you should assume that the central directory is at the end. So like, look at that. And then the rest of the file contents in the front.
So it's kind of weird. You would think they would have seen the second file. But either way, I guess it doesn't matter. The threat actor just has to know his target compression tool. And if 7-zip only decompressed the first, they could have easily made the first the malware if they wanted, and the second the fake one.
So in this case, they're pretending like, let's say the researcher that's trying to defend against this is using 7-zip. They open up the zip archive. All they see is this benign file, and they go, okay, yep, this is clean, and let on the file to the victim. But let's pretend the victim is either using WinRare. I'm sorry, I still call it rare. It is rare for the rest of my life. It's rare, whatever. And Windows Explorer. Exactly. In both of those cases, so using WinRAR or Windows Explorer, it uses that second central directory, and so it grabs the file from the second archive in there. So completely different behavior on which file you see and which file you get.
It might be acting more correct, because if the central, if that one central directory is supposed to be at the end, it makes sense that the second file would be seen first.
Now there's one caveat in this. If you send it as a .zip attachment, Windows Explorer actually throws an error for a invalidly formatted file. If you change the attachment name to .rar though, even though it is still a zip archive, but with the .rar extension, Windows Explorer can open it now, and it shows that second file.
And by the way, I think all compression utilities will open a RAR that has the wrong extension, or a zip that has a wrong extension, because I think it's very common for bad guys to use .rar in emails, even though it's really a normal zip. And they might be knowing that people are blocking or doing extra stuff on zips, so they're trying to evade email protection by changing an extension.
Yep, I think that's probably a common tactic. In this case, though, like, the reason they started looking into this is they actually found some real-world attacks leveraging this. There was an example Trojan malware that was described as a legitimate shipping document in this case, where it was using zip concatenation with a .rar extension, even though it was a zip file. The first one actually had a benign PDF in there. It was just called like x.pdf. So if you opened it in 7-zip, you would get a totally safe, benign PDF. But if you opened it in Windows File Explorer or in WinRAR, it would instead load up a malicious executable, which was an AutoIT malware variant in this case. So attackers are currently using this technique. And it's interesting because it could allow them to evade some detections depending on how they handle that type of unarchiving. Like I could see
Concatenation.
maybe a network security device maybe handling it one way that lets it through. But at the end of the day, like an endpoint anti-malware system would still see that malicious
As
file
soon as
as
you
it's pulled out.
uncompressed it. Yeah, yeah.
Exactly. So you're not totally hosed in this type of attack. But I don't know. Either way, it's pretty interesting seeing how you can abuse file types like this to have it behave in different ways depending on how the utility tries to handle a technically invalid file.
And it sounds like they don't plan on fixing any of this because it's how it's designed to be.
Yep, exactly. So I guess if you're a SOC analyst and you've been tasked with reviewing a potentially malicious zip archive, maybe now open up in two different utilities instead of relying on your trusty 7-zip. Also try it out in something else and make sure that behavior doesn't change depending on the utility that you're using. But great, even more work for us SOC analysts to handle when it comes to funky files like this. Anyways, moving on. The last story I wanted to talk about, and Corey, man, it's been like over a month since we talked about something from CISA, I think. So it's
Wow.
definitely time to talk about another
Our
advisory
best
from
friends
them.
have been ignoring us.
I wanted to give them a break, I guess, while they were focusing on election security. And now that that's done, dot, 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 we can move on to actual security news out of them again. Where just this last week, CISA co-authored an advisory along with the FBI, NSA, and all Five Eyes international partners, so Australia, New Zealand, UK, and Canada, a report from 2023 on the most exploited vulnerabilities from that year. And they gave a list of 15 of the top ones and a handful of other ones. But there was some pretty interesting takeaways in here, not just from the list of vulnerabilities themselves. Like the first thing that stood out to me was like in the first or second paragraph, even, where they said that in 2023, the majority of malware frequently exploited frequently went after vulnerabilities that were initially exploited as 0 days. And compared to 2022, only less than half were 0 days at the time. So attackers were moving away from going after like, let's call it 1 day or at least known vulnerabilities and basically finding their own and exploiting them. And that's how we as defenders caught them eventually. And just pausing on that, like that's not surprising to me. It felt like last year was the year of like active exploit 0 day from a whole bunch of different software vendors and systems manufacturers. So I'm
This
not
is
totally surprised.
pure speculation, had. Now, first of all, nation states probably do hire a few vulnerability finders that can probably find 0 day relatively easy. But nation states also have enough funding to push AI. And we saw, I think it was as far back as it was a long time ago, we saw the DARPA challenge where AI can find 0 day vulnerabilities in software. So this is pure speculation, nothing to do with this report, but I'm curious if the nation states finding these flaws are just normal human vulnerability research, or if they're actually using all the money they've put into AI development to actually use it to find vulnerabilities in products they're targeting.
That's, I don't
Just
think
a
super
speculative
tinfoil hatty.
question. Yeah.
There's definitely
It's the
some
kind of thing
foil in
that's
that hat, but I
possible,
don't
but
think
we
it's
just don't
entirely
know.
made. Yeah,
A glittery foil.
exactly.
There's,
Your
there's a
hat's
little
at least,
tinfoil in the unicorn part. That's it.
yeah, shiny, but not entirely made of tin. Um, but even beyond that, though, they then went into like the actual top 15 most exploited vulnerabilities. And we won't go into every single individual one, but like to summarize, the first two were vulnerabilities in Citrix NetScaler.
VPN. Oh, wait,
Yep.
no,
The next
NetScaler.
two were vulnerability. Yeah, remote access. The next two were in
Okay.
Cisco iOS. So again, networking equipment. The next one after that was in FortiOS and the FortiProxy VPN. Then there was
Remote
the
access, remote access, remote
yep.
access. Or
Then there was
management, management, management.
the Progress Move It file transfer vulnerability. That one was
We
pretty
all
big and it's
remember.
still causing issues. I think I just saw a news story last week for like Delta and Amazon and like a bunch of other big companies getting nailed with this vulnerability again. Atlassian Confluence was in there. Log4Shell was in there as well too. Then there was the Barracuda Network Email Security Gateway vuln. That was the one where you had to RMA your device if you were affected by it because the implant was so pervasive. The Zoho Manage Engine remote code execution issue. Then there was a couple I don't think we've talked about on the podcast yet, but Papercut NG, it's a print management software. It had a remote code execution issue that made the list. JetBrains Team City, which is a development like CI/CD tool I had never heard of until now. It made the list also. There was the Outlook authentication bypass slash privilege escalation issue from later in 2023 that made the list. And then OwnCloud, which is like a cloud hosting system. They had a authentication or information disclosure vulnerability that made the list too. But Corey, you already pointed out the first major trend that I saw while reading through this was that is a whole lot of like network and remote access equipment right
Yeah,
up there at the top. And I think
not
that
too
makes sense.
surprising.
It's what we've talked about a few times, especially recently with like the Sophos article and the wave of like Fortinet and now Palo Alto issues, where these are obviously devices under attack because they're network exposed by nature. So it makes sense that if there was a vulnerability in one of them, attackers would leverage the heck out of that to go after organizations.
Yep, for sure.
But the others were systems that I feel like they probably shouldn't be internet exposed, but they probably commonly are. Like print servers, like you should not have a print server on the internet. But I could see
Unless
how
you're
a
like a who? Why can't I think of one right now? I, actually you're probably right. They should have a web service in front of it. But there's like remote you can buy on from at home, order prints and go pick them up. But that shouldn't be with a direct print service. That should be via a web
correct.
interface.
Exactly. Yes. Like I
Yeah,
wouldn't put my copy machine on the internet, for example.
yeah.
Things like Zoho Manage Engine and like other RMM tools like should not be internet exposed, but I could see how in
Those
some
commonly
cases.
are. I mean, that's
Yep.
where, besides remote access management interfaces, they shouldn't. Like remote access and VPN, you get why that's exposed. Management commonly is exposed, but really never should be. The management should be behind a VPN, and that exposed remote access or VPN should be behind MFA. So, but
Yep.
yeah,
I mean, we're not going to really focus on it on this episode, but even Palo Alto just put out an advisory on a actively exploited zero-day vulnerability in the management interface for their network appliances, which again,
yeah,
like management
never should
interfaces
have
should
been
not
put
be exposed
online.
to the internet.
Yeah.
Yes.
I mean,
And I
yes,
would,
Palo's fault for a flaw, but not Palo's fault for customers putting their management interface on the internet.
and I'd hope that if you had the budget to afford a Palo Alto device, that you'd also have a security team that was knowledgeable enough not to expose that thing to the internet. But apparently, we're proven wrong in some cases. But they went on. They also published like a whole list of like 30 other issues. A lot
50
of like
some, yeah,
Juniper,
total.
Avanti issues. There were some Apple ones, so there are some issues affecting desktop applications too. But again, it's all overwhelming majority are like internet exposed services and specifically network equipment as a prime target for threat actors in that year. And while
And
this
we're
was
seeing, we've said
2023,
it before, but even we've seen Fortinet, Sophos, ourselves with Psychopus Bing, Cisco, and now you just mentioned the PanOS story. It's clear threat actors are targeting this network equipment.
yep. When it comes to the mitigations, they gave some advice to like vendors and developers, and it's basically follow CISA's secure by design and secure by default principles, like track metrics around vulnerability classes, engage leadership, adopt secure development frameworks, that sort of stuff. They also had some guidance for end user organizations too. So have a good, robust vulnerability and configuration management program, which should hopefully prevent you from having stuff like this exposed to the internet if you're following best practices from that.
Patch, patch, patch.
Yep. Routinely perform automated asset discovery to make sure that you're aware of everything that might be exposed. patch management's the big one. Document and secure all baseline configs for IT and OT components, and then perform regular secure systems backups to create good copies of all known configurations so you can quickly recover from an incident too. But overall, like, this was a 30-page document that was more than just a list of vulnerabilities. There was a decent amount of good advice in it. And even that first stat of just calling out that attackers are shifting focus, or at least the most common issues are shifting focus to going after 0 days. It's basically what we've seen for the last 2 years. And I imagine when they release their 2024 report sometime next year, it'll probably be even more of the same in that case too.
Yep.
And man, I wish Log4Shell would just die, but apparently
It
that's
must be the
gonna stick around
industry's
for a while.
fault. I mean, we knew it was a ubiquitous enough package that it's in everything. But at the flip side of that, it's been known for years, and everybody and their brother in security has been, and mother and sister and cousin and aunt have been talking about it. So there is no excuse that you still have a vulnerable version of it around. But it was pretty ubiquitous.
It
Is pretty
absolutely was.
ubiquitous.
And the ease of exploit was just insane, an insanely low barrier as well too for going after something that had it. So either way, the report ID is AA24317 alpha if you want to take a look at it. I think it's worth it. And yay, we only went 1 month without talking about CISA. So I feel better now. That's good.
I wonder
And
if it's going to stick around, or if or if what is it, the government of something redundancies, the made up new cabinet members will get rid of it as a needed regulation.
I
Sorry, I'm being spicy.
that actually makes me really upset because of all the organizations. This is definitely one that you could
It's a good
categorize
one.
from that
Yeah.
perspective as, yeah, let's get rid of it because it's a unauthorized regulatory arm. Dang it, Corey. That
Did
makes
I
me
give
sad.
somebody an idea? I hope I didn't give the people listening an idea. Maybe they'll just forget about it and not realize it exists.
Maybe we'll see. Hopefully, man, that makes me sad.
I
But
wonder if
for
it's
now,
under
thank you, CISA.
DOJ. I guess we'll find out. Yeah,
It's
we
under
like you,
Department
CISA.
of Homeland Security, and hopefully, by being under that department, it keeps its budget. I guess we will see. Hey everyone, thanks again for listening. As always, if you enjoyed today's episode, don't forget to rate, review, and subscribe. If you have any questions on today's topics or suggestions for future episode topics, you can reach out to us on Instagram, or I actually just signed up for a Blue Sky account, Corey, and you probably should too. All the researchers are making their way there. I
Blue
am
Sky and Threads.
at itsmark.me if you want to find me on there.
Gotcha. At itsmark.me. It's smart,
Got
huh?
my own vanity domain just for that.
Not to pimp other podcasts, but Hard Fork has Threads as the number one, and Blue Sky is the second.
I
It's a go-to if you don't like
willingly
X.
cannot willingly join another Meta product. So Blue Sky it is. Anyways, you can also, speaking of Meta products, find us on Instagram at watchguard_technologies. That is Meta, right? Yes, it is. All right. Thanks again for listening, and you will hear from us next week.
Bye.